Yeah, we got that tomorrow.
That's tomorrow.
He was talking about
The last test, Mr.
Last
Lippy.
test, really?
Yeah. Think about this, because Monday.
May 1st.
Yeah, Monday,
Lab
May.
ceremony that morning.
Right. There's that. Tuesday, Wednesday, late starts. Thursday, I won't see these guys because it's the senior walk.
Correct.
And then Friday.
Are you guys got AP testing Friday?
Oh, there's AP testing all over the place. It's like crazy.
Yes, and then your finals.
Right. So I gotta.
Yeah, you gotta hammer them.
It's the same thing with Cal.
Whatever you can do to put the screws to them.
Right. That's right.
Yeah.
1613. All right. Okay, a researcher claims that the number of cups of coffee U.S. adults drink per day are distributed as shown. You randomly select 1,600 U.S. adults and ask them how many cups of coffee they drink per day. The results are 0 cups is 570 people, 1 cup, we see that there. At the alpha 0.05 level, test the claim. What is the null hypothesis always for this type? The distribution is as shown, right? When you're wondering about, when you're looking at is this distribution correct, that means the null hypothesis is that the distribution is as shown. You know, if you look in your book for any of the answers there, they actually state out the entire distribution. You know, they would say the distribution is 0 cups is 36%, 1 cup is 26%, 2 cups is 19%. But we can just say the distribution is as shown. So what's the alternate? It is not as shown. Yeah, right? So make some sort of statement. The distribution differs. The distribution is not the same. The distribution is something else. Whatever you want to say there. All right. So let's first start off by finding our rejection region. Is that okay? Okay, so for my rejection region, the alpha is 0.05, right? The alpha is 0.05. What's my degrees of freedom? 4. Right? The degrees of freedom is 4 because we have 1, 2, 3, 4, 5 categories minus 1, so degrees of freedom 4. Okay, so let's figure out using the chi-square table. And the chi-square table, just so you guys know where it is on the very back of the yellow packets. Yeah. So the chi-square distribution is got 0.05 with an alpha 0.05 with degrees of freedom 4, 9.488. I feel like we've used that a bunch. 9.488. 9.488. That's our chi-squared critical value, right? Now, the chi-squared test is always a right tail test. So that means that our rejection region is when chi-squared turns out to be greater than 9.488. If that is true, then we can reject the null, right? All right, so let's actually find chi-square. Now I'm going to go back up here, and I'm just going to kind of make additional columns to the table. Okay, so let's find O, then E, and then we're going to find O minus E squared over E, because that's chi-squared. All right, my observeds. 570, 432, 282, 152, and 164. Let's find my expecteds now. And remember that if I take 1,600 U.S. adults, I'm going to take 1,600 times my expected. 1,600 times my percentage. 0.36 times 1,600, which is 576. So pretty close. We've got 0.26 times 1,600, which is 416. little bit further off. 19%. 0.19. 304. 150, or sorry, my 8%. Not 0.08, not 0.8 times 1600. 128. And then we got 11%. 0.11 times 16. Which gets us 176. We good so far? Pause it for a moment. We good? All right, next step. For real?
Yeah.
It's like a real movie.
No, I don't know. But she mentioned something about Minecraft. Looks like Romeo and Juliet.
That's Minecraft.
That's Minecraft. That's Minecraft.
That's a Minecraft thing,
That
right?
is 100% Minecraft.
Is that-
people.
Is it like a crossover?
I don't know, but that's Minecraft.
I hear the Minecraft music. That's
Yeah.
why I questioned it. And that looked like the Minecraft
I say
movie.
we all storm the room and ask her.
What's going on in here?
Just open the door and be like,
That's
"No."
okay. We got statistics to do, okay?
No, we don't.
All right, so let's do O minus C squareds over E's. Okay, we got 570. Okay, so 6 difference squared divided by 576. Small number, 0.06. Okay, let's see what we got for the next one. I can do this in my head. 432 and 416, the difference is 16. 16 squared divided by 416, which is 0.62. 304 minus 282, 418, 22. 22 squared divided by 304. 1.59. 128 and 152. What's the difference there? 24? 24 squared divided by 128. Uh-oh. Starting to get bigger. 4. Oh no, 4.5. We're going to have to reject this, aren't we? It's getting closer. It all depends on this last one. We got 12 squared.
But you will be good.
You think?
Lately,
0.82.
lately, it says things will be good.
You think? Okay, cool.
There's no way
I
that.
trust him. He knows what he's doing. 0.06 plus 0.62 plus 1.59 plus 4.5 plus 0.82. Bingo. Okay. So we got our chi-square to be 7.59. So chi-square is equivalent to 7.59. And we can say because 7.59 is not greater than 9.488, we fail to reject the null, right? If we were, again, I guess this depends on our angle, but if we were the person to create this distribution, this is what we wanted to happen. We want to fail to reject because I was hoping to not disprove my distribution. So we can say there is not enough info to reject the distribution. Not necessarily, again, knowing that the distribution would be correct, except it's just that we don't have enough information to show that it's not correct. Not guilty. Just come back. Have a good day. You too.
He's just going to talk to Esquire for a minute.
Okay. You
He'll
coming
be
back?
back.
I'll be back. Okay, cool. Let's do, because that was one problem like 10-1. Can we do one on the back so that we can at least get one problem by each type?
Yeah.
Let's do that because we might run out of time. We might not be able to do all 4. The contingency table. The contingency table shows the results of a random sample of students by the location of school and the number of those students achieving basic skill levels in 3 subjects. At the alpha 0.01 level, test the hypothesis that the variables are independent. All right, so the null is that it is independent. The variables, how did I put it yesterday? The variables are independent? What did I say?
I'm good. Variables are- We can take a look.
Variables are independent, variables are dependent.
Variables, for handwriting, variables are independent. And the ha is the variables are dependent. Let's find my rejection. Well, at the alpha 0.01 level, what's my degrees of freedom here?
Yeah. We got 2
Three,
times
two.
1
Two.
is 2.
It's a lot of numbers. 4, 3, 3, 2. What?
Two.
2, 3.
Don't worry, drop this.
It's 2.
It's 2. 3 minus 1 times 2 minus 1. Right? 3 columns, 2 rows. 3 minus 1 times 2 minus 1. So it is dose.
3 minus 1 is 2 times 2 minus
Minus
1
one
is 1.
Two
So
times
3
one.
times 1 is 3.
You know.
What?
There are 3 up here, right? Minus 1 is
2.
2.
Got it.
There are 2 here. Minus 1 is 1. And then 1 times 2 is
Oh,
3.
4.
we got it.
6?
I was really confident before.
We got degrees of freedom 2. Okay. 0.01 level? 9.210. 9.2. Oops, nope, that's not an alpha, that's a chi.
Is this still chi-squared?
Yep, chi-square critical value is 9.2, I forget it now, 210. So that means, now again, this is a right tail test, correct? Both of these are always right tail. So that means if our true chi-square turns out to be greater than 9.210, we reject the claim that the variables are independent. Okay? All right, so now this is my observed, right? This is my observed. Let's calculate my expected table. Now, for my expecteds, what do I need to find? And what do they call that? Marginal frequencies, I think, in the book. They call that marginal frequencies. So we're going to take 106. This is 108. And this is 103, I believe. This is 85 plus 38. 123. Uh-oh. Hold on. I'm getting a phone call from healthcare.
Uh-oh.
I don't know who that is. Hold on, take this. Hello? Yes.
Who finished this?
We gotta get the totals for don't we?
You told those two.
That is 317.
Do we trust him?
Yeah.
I'm going to trust him. Okay, now let's find our expected chart. So we got urban and suburban, and then we got reading, math, science. Now, how do we find our expecteds?
You multiply the 106 times 103 divided by 317.
Yeah, we take the 106. So this is for urban reading. 106 times 123. And we divide it by the total, 317. So 41.13.
That's it.
Pretty close, right? Let's find urban math. 108 times 123. Is she still talking about Minecraft?
Yes.
41.91. Urban science. 123. Divided by 370. Bless you. 39.97. Pretty close, right? Yeah, what's wrong?
I have a question. Will the formula for like how to find the expected be on the yellow sheet?
I believe so, but let me double check.
Should we just take the difference, save some time for the second round?
Let's do the look method.
I like the loop method.
The what?
The look method.
Subtract
On the second row.
You heard by that?
The look method here.
It's not. I'm surprised at that.
Yeah,
I mean, you get the chi-square.
it's okay.
Yeah.
It's kind of
Thank you.
loop method.
I'm gonna multiply them and then divide by no. Okay, so it should total of 106, right?
Huh?
106 minus 41.13. 64.87. And then this is a 108. 108 minus 41.91. 66.09. And I've got 103. 103
This is really close.
minus 39.97. 6303. Okay, so now we find the chi-square table, which is going to get me the urban, suburban, reading, math, science. I hope I didn't make these boxes too small. Again, O minus C squared over E. O. 43 minus 41.13 squared divided by 41.13. Whoa, 0.09. Urban math. 42 minus 41.91. Yeah, O minus E
Divided by
squared, don't forget the squared, divided by E. Whoa, whoa, whoa. 41.91. Yeah, that's gonna be a 0, 0.
left there.
Yeah, O minus C squared over E is right.
I don't think we were back.
I don't think so. Oh, there's no way we would.
You don't think? Well, yeah, there's no way we're gonna get up to 9, right?
I'd be in disbelief.
So we got 38 minus 39.97 squared divided by 39.97. Oh no, 0.1. Oh geez, that's a giant number.
We're way closer than that.
Yeah, we're way closer to that. Okay, suburban 63 minus 64.87 squared divided by 64.87. 0.05. Okay, we're back on track. Oh geez, this is another 0.09. I'm gonna call it. That's 0.00. 65 minus 63.03 squared divided by 63.03. Oops. 0.06. Well, whatever this is, it's not going to be bigger than 9, is it? 0.09 plus 0.1 plus 0.05 plus 0.06 gets me 0.3. Only 0.3?
Is that right?
I'd say. I mean, it's reasonable because the distribution is so closely matched to what our expected. Right. So we can say 0.3. Yeah, the flight pattern must be flying right over us. Is not greater than 9.210. So therefore, we fail to reject. So we can say that there's not enough information to reject that the variables are independent. Not enough. Whoa, that's a big N. Not enough info to reject that the variables are independent. Mr. Richard Kassenheiser, just be very careful everything you say is being recorded. Just warning you. Sound good?
Just regular storm.
Oh, 3D printing.
I showed you the Iron Man one.
I have it.
What?
It's in my-
You wanna see the Iron Man one?
Let's still talk about Minecraft.
They are still talking about it. What's a different class now?
Oh, they do say.
Learning about Minecraft again.
Design school, right?
Do we feel like we need the other two examples? Or are you guys good?
I think we're fine.
I feel like you guys are good
I think it'd be good practice.
Yeah,
What?
to do it.
No, I wasn't gonna say to do it. I think
go to war.
good practice for me tonight.
Yeah, honestly,
That's
that
what I
is
was
true.
gonna say.
If you want a couple extra problems to do.
Uh,
All right.
Is the answer key on?
This is literally.
I don't, probably from last semester, I think I did them all. I'll just keep that video on there.
This is literally just like